Perfect. So then, yeah, that can wait. This is not major, but if you want to start with that, that's fine. I can do it at the very end. So then, yes, Steve?
If you want to add addition of 0x?
No, because this is already completed square. There is no term with x, so I don't have to do anything to that. That's the lucky part. There is nothing with x, so there is no need to do anything to that. It's already completed square. But if you want, you can say it's x minus 0, everything squared, which is the same thing. Perfect. What do we need for y? We need to add something to both sides. 9 indeed. The middle coefficient divided by 2 is -3. -3 squared is 9. And that's how we get x squared plus. And this is 16. But please tell me what is this and this and this in here. I will not get the middle coefficient to be negative if I put +3. Indeed, -3. Is that clear? Okay, perfect. That's it. So what is the center and what is the radius of this circle? Very good pick. Thank you. It really was good. Okay, very good. The radius is 4. Excellent. And the center? Very good. I said a minute ago x minus 0. So if you don't subtract anything, you have to write 0. There is nothing I subtract, nothing I add, so it must be 0. And y minus 3, then k is 3. Are we feeling a little bit better? Yes, it's the same procedure. It's just that we applied twice, and we applied it twice in the first problem, and we only applied it once here because x was already a perfect square. It was x squared. Maybe if this is better for you, you can write it as x minus 0 squared plus. But I think that this could be more confusing, but it's up to you. Whatever works. Good.
Can we do 64?
Of course. Let's do 64. So we have x squared plus y squared plus 3x plus 5y plus 9 divided by 4, I think. Is it 9/4? Good. Thank you. Of course, this situation is slightly more difficult. Why? Because 3 is not divisible by 2 and 5 is not divisible by 2. So obviously, we have a little bit of a fraction work there. So then, yes, you can move 9/4, but I don't recommend you focus on that. This is not important. So I have x squared plus 3x. What do I need to add to both sides? I cannot divide 3 by 2, so it has to be 3/2. And then when I square 3/2, what do I get? 9/4. And look how lucky we are. Wonderful. That's why I recommend don't start by moving the bad number, because maybe it's helpful. Maybe you will combine it and you don't have to add and subtract 9/4. In this case, I don't have to add 9/4 to both sides. It's already part of the problem. So then this and this and this are right here. What? What is in there? Plus, sorry. What is in there? Yes? Yes? 3/2. Of course, what we squared to get 9/4. It must be it. Absolutely. Good. Plus. Now this is a different situation because I have y squared and I have 5y. So it's 5. I divide 5 by 2. And now I have to square that. What do I get? Over. Good. So I have to add 25 over 4 to both sides. And now this and this and this are here. And the right-hand side is only 25 over 4. But now please tell me what you have in parentheses. Right here. Say, yes, indeed. There is no minus here, so I cannot put minus. Perfect. I'm sorry, I didn't hear. My apologies. That's okay, sorry. Indeed. What I squared to get this number. Excellent. So now we need the coordinates of the center and the radius. Very good. But negative. Good. And negative 5 halves and you remember you squared this to get that, right? It's right here. 5 over 2 indeed. Okay. Questions for me? It's a very, I already said that. This is not a major topic. No, I don't consider the major topic. It's nothing really. So it will be probably one of the extra credit problems. But it's really nothing. What you will be asked to complete the square. So you have no choice. There is no escape. So why not practice this completing the square? So it's not a big deal. You just practice a few and you'll become experts. Trust me. So this completes chapter 2. It took us what, a month and a half? The entire February, a class in January, and one in March. Okay. So let's continue. Any questions for me? Is there anything from this chapter that you would say I would like to review or would like to go back? We only had one test, so we have 2 more tests and the final exam. You mean the standard form of which equation? Of what? Yeah, so this is what we just did. Given the center. Sure. So, yes, of course. Given the center and the radius, find the equation. That was one type. The second type, given the equation, determine the center and the radius. And here's the third type. Given some gibberish, right, if you want, is this the equation of a circle? I have no idea. So we came up with completing the square twice, once for x and once for y. We came up with this, and now we were able to determine the radius and the center because it was the equation of a circle. These are the only 3 types. Is that okay? Yes, I touched up on all of them, of course, till you get ready to sit down and redo these problems first, and then work on other problems to test yourself. Of course, you need some time. I don't expect us to carve it in stone already after seeing 3 examples. That's not enough. I know that. Perfect question. Anything else? Thank you. Anything else? Is there anything else you would like to go back to? From anything from chapter 2, but obviously 2.5 to 2.5 to 2.8 because everything else was prior to 2.4 on test 1. So 2.5 through 2.8, as well as 3.1, as I mentioned, 3.2, 3.3, 3.5, and 3.6. As you know, at the end of the syllabus, you don't have to copy this. They're at the end of the syllabus, and you also have work in my lab's math. Okay, so if we start 3.1, which I would love to, this is a complete review, but I will not treat it as a complete review. I will start from scratch. It only deals with quadratic functions. But I would like to ask if you have any questions. You want to go back to anything before we look at quadratic functions? We're going to look at the models with quadratic functions. We are going to look at the graph of a quadratic function. And then, of course, as I said, models or word problems. Anything for me before we start? I know we have only about 12 minutes left. Anything else? Is there any problem from the computer work that you would like to go back to? Yes, please. Yes, I'm ready. Which one?
No, I said I haven't started that, but I'm just
Okay.
looking through the textbooks and I see that there's some word problems that deals with finding the distance to the nearest mile between each pair. It's on page 3.
Yeah, let's look at that. Once I have the 2 points, I can always determine the distance. Give me any 2 points, anywhere. Yes, page.
333.
Correct. And which problem?
Let's try 73.
73. Very good. So a rectangular coordinate system with coordinates in miles is placed with the origin at the center of Los Angeles. And that's normally how they do it. When you try to determine the distance, let's say between Baltimore and Los Angeles, as an example, they calculate the distance between the center of the city that is considered the center of the city and the center of Los Angeles. That's how they calculate, not to the Beltway. I know Los Angeles doesn't have a Beltway, but you know what I mean. Okay, so they're saying.
What they call the freeway?
So this is 73 on page 333.
It's not section.
No. It's still in 2.8. We're talking about the circle. Yeah. So it's located. So say it again, TK. You wanted me to show something, or? Oh, okay. So the figure indicates that the University of Southern California is located 2.5 miles west. So here's the center, and 2.5 miles west. This is west direction, east, north, and south. It's located 2.5 miles west and 2.7 miles south of central Los Angeles.
Should that be 2.4 instead of 2.5?
Is it? Oh, it is 2.4. Sorry.
That's fine.
So west 2.5 and south of central Los Angeles. So one more time. Yes, 2.7. So we are talking about not this, but we are talking about the point negative 2.4, negative 2.7. So here is the center of Los Angeles. 1, 2, 3, 1, 2, 3. Negative 2.4 roughly, and negative 2.7 again roughly will be here. So if this is the center of LA, this is the University of Southern California, USC. Perfect. And we know the coordinates of USC. Now let's see what they want. A seismograph on the campus shows that a small earthquake occurred. The quake's epicenter is estimated to be approximately 30 miles from the university. Write the standard form of the equation for the set of points that could be the epicenter. So 30 miles. So that's where the university is, and this is a radius of 30 miles. Everywhere. 30 miles, 30 miles, 30 miles. That's the radius of 30 miles. So we are asked to determine the equation of the circle. Knowing the center is exactly what? Very good. Negative 2.5, negative 2.7. And the radius is exactly 30. Now we have to make sure that everything is in miles. Because if the measurement unit, so yes, we had 22.7 miles, 2.4 miles. Everything is miles, 30 miles. That's it. So I have the center and I have the radius. I'm asked to find the equation of the circle where the earthquake could have occurred, anywhere inside the circle. So remember the equation of the circle. You have to write it at least, I don't know, 6 or 7 times or more till you get used to it. Otherwise, you may forget it. Good. So then, what should I write? X plus 2.4 everything squared plus everything squared equals 900. That's it. That's the equation. Yeah, you had to plot the point. You had to think about what it was giving us. And you have to plot the center. And then try to find the equation of the circle. Because the epicenter could be anywhere within 30 miles away from USC. Very good problem. Very interesting. Good pick. Good. So anything else? Anything else? Okay, so 3.1, again, everything here is a review in 3.1. But I'm going to start from scratch. So quadratic. If you find something else, I can stop anytime. Quadratic functions. They're given to us in 2 forms. They mean the same thing. Here's one. And here's the other. Exactly what Ben said. What's with that agent K? Yes. We have absolutely no secrets here because we use transformation. So I'm going to start with this because it will take us a shorter time than with that. So let's suppose I'm given a quadratic function that is -2 x minus 1 squared, let's say plus 8. Without doing anything, can we visualize this graph? Of course we can. We cannot visualize this one, no matter what A, B, and C are. But this one in a blink. So we're not even doing anything, right? I have x squared. Where does the graph go? First, to your right one. Perfect. Then what do I do? Stretch it by a factor of 2. Then what do I do? Flip the graph. And then what do I do? That's it. I know the graph. One more time. X squared. 1 to your right. Stretch by a factor of 2. Flip the graph with respect to the x-axis. And up 8. Can anyone give us the vertex? Which is the maximum point, in other words, for this function. Exactly. The vertex is indeed h comma k. That's how we got the 1 and the 8. We haven't even graphed the function and we were able to determine the vertex. Are we able to determine the range? Of course we are. Because we already have this graph in the back of our minds. So what would be the range? -infinity till? Exactly. And we haven't even graphed it. Just because we studied transformations on this function. Okay, so first question here is, if you remember, and we discussed that, the graph of a quadratic function is a parabola. A parabola can open upwards or downwards. So these 2 points, this is a vertex, and this is the vertex, plural vertices. So every parabola has a vertex, either which is a minimum or which is a, of course. Now, how do I know the shape? How do I know if it's this or this? It's the leading coefficient. The leading coefficient is what type of number?
Negative.
Right, when the leading coefficient is negative, the parabola has a maximum. When the leading coefficient is positive, the parabola has a, yes, indeed. So in this case, in our case, the parabola has a leading coefficient that is negative. So that's why this is our case. In step number 2, I'm going to ask you to find the vertex. Well, you don't need to find the vertex because we just determined it. So what is the vertex of the parabola? Very good. Number 3, I have to find the x-intercept, comma, if they exist. What does that mean, if they exist? So let's talk about a maximum because that's our case. There are 3 possibilities for a maximum. Here's one. Here's the other. And here's the third one. Of course, the same possibilities exist for a minimum. But how many x-intercepts do we have here?
2. Oh, I'm sorry, I got excited.
I want you to. I want you to. 2 x-intercepts. How many x-intercepts we have here?
1.
Well, we're going to say 2, but it's just 1. It's still the vertex. The x-intercept and the vertex are the same here. How many x-intercepts we have here?
No.